G'day. So, chemical reactions. We all love doing chemical reactions in class. That's always the fun bit. So what are we talking about here when we talk about chemical reactions? Well, essentially, you've got a number of substances. They can be compounds, they can be elements, and we cause them to mix together and create new products. And so we look to see what has happened from that experiment. What sort of new product did we get? Okay, so we have two types of change we can look for. There are physical changes. So in that case, often we don't get a new substance, but we'll have changed some properties. So the piece of bread being made into toast is an example of a physical change. We've changed the properties of that piece of bread, but it's still a piece of bread. We've burnt it. Whereas with chemical changes, we often change the properties of the material. So we put two things together. It's a classic one I do with my students often. Two clear liquids, put them together, all of a sudden we got a yellow solid. So we change things quite a bit by mixing these two things together. There's been a chemical reaction which has done some interesting stuff. So how do we know if there's been a chemical reaction? Well, we'll certainly know if there's been an explosion and also gases and light given off. Let's hope we don't do that in class. So we can produce gas, and you can see bubbling. You don't have to have quite the massive explosion there. We will maybe produce light or heat, or it takes up heat sometimes. So it uses the energy. We can see a change of mass. We can see a permanent change in the colour. Or we can see what's called a precipitate form. So we get some solids in the solution and they fall to the bottom of the test tube or the beaker. So they precipitate out. These are really good signs that a chemical reaction has taken place. Now this guy you'll get to know. This is Antoine Laurent Lavoisier, and he lost his head to the guillotine, not because of his chemistry, and he was actually a well-regarded chemist across the world, had won plenty of prizes and brought plenty of notoriety and fame to France. But in the Revolution, because he was a tax collector and an accountant by day, an amateur scientist by night, the revolutionaries saw him as one of the enemy rather than one of the good people, and they took his head off. But he came up with this wonderful statement that still hangs in there, 1750, so it's been going for a while. Matter is neither created nor destroyed, rather is simply transferred or transformed. So because of him, science students all around the world whine about having to balance their equations because they're quite hard. This is a simple one I'll use here, but it gets quite hard to do it. But because he was an accountant, he realised that the things you start an experiment with, the reactants, must all go somewhere. You can't just lose them. So in the products, in the things that come out of the experiment, you should be able to find everything. So the classic is the formation of water from hydrogen gas and oxygen gas. So hydrogen gas and oxygen gas in the atmosphere are H2 and O2. So there's two atoms of in each molecule. But when we make water, we get H2O. We've lost an O. We've actually lost an oxygen. So you can't really do that. It's got to be somewhere. So to balance the equation, Lavoisier realised that what we have to do is play with the numbers. Now you see all these two red numbers. I can't change the numbers in subscript, the little numbers, because that's how the molecule is made. But I can change how much of each molecule is present. So if I have two hydrogen molecules, then I've got 4 hydrogen atoms. 2 times 2, that 2 times that 2, 4. Yeah. Over here, I've now got big 2, little 2, 2 times 2, 4. I've still got just the one oxygen molecule, 2 atoms, and of course 2 times 1, we don't write the 1, but 2 times 1 is 2. So there's now 2O on that side. So we've now balanced the equation. I'm not going to get you to practice that. There might be some on the style sheets, but normally we'd spend some time balancing equations. It's just maths, and it's really accountancy. It's maths being applied in a way to account for the reactants and the products. So once you get the hang of it, it's pretty straightforward, but some of the experiments can be quite messy. So you've got some stuff to do now. There's some lessons on style, some of the theory, some of them practical. If you want to do a prac, let me know, because we need to, especially in advance, because we need to get that sorted with Mrs. Parry. And then once you've worked out what you understand about chemical reactions and production of new compounds, you need to think about how we can use that knowledge to address specific problems or issues and make a presentation about that to the class. And again, it doesn't have to be you staying in front of the class. It can be, but you can make a video, you can make a poster, all the usual sort of stuff. Don't forget your references. Okay, I'll see you back in class.